Good afternoon, everybody. I'd like to thank you all for coming to this open lecture that we are having under the Erasmus Mundus in ECOHYDROLGY. I want to thank you all for coming to this session, and the ones that are here at the room, and also the ones that are assisting through our webpage. I would like to say that this open lectures are supported by several institutions and programs, so are under the Erasmus Mundus Master Program in ECOHYDROLGY, but are also under the University of Algarve's Faculty of Science and Technology, are also under the UNESCO International Center for Coastal Ecohydrology and the UNESCO Ecohydrology Program, also are under the OIC's regional nodes for Europe, and are also promoted by the Center of Marine and Environmental Research of the University of Algarve. For this lecture, we have the big pleasure to have and honor to have with us Professor Eric Wolanski from James Cook University, and he's also a senior researcher from Australian Institute of Marine Sciences. And Professor Eric Wolanski is more than well known worldwide. Anyway, I will tell you that he has more than 350 scientific papers that he published. He published also more than 7 books, and I will ask for special attention to this last huge publication that is a 12-volume treatise in estuarine and coastal sciences that Professor Wolanski is chief editor. He also is Dr. Honoris Causa from Catholic University of Louvain in Belgium. He is the chief editor of Estuarine Coastal and Shelf Science, and also of Wetland Ecology and Management Scientific Journals. He is a member of scientific and policy committees of OICs and EMMC. So I can continue with all these huge achievements that Professor Wolanski has did through all this scientific life, which are amazing, but mostly I would like to thank him for the opportunity that he is giving us to share with us all his knowledge and his experiences, and it's a huge amount of work done in several parts of the world. And better really is to listen to his conference that is entitled Recovering Tropical Lagoon Ecosystems from the Impact of Climate Change. Professor Wolanski, thank you so very much for being with us, and I wish you a great talk. Thank you.
Is the sound okay? Is the sound okay? Okay. The theme of the talk I give today is using biophysics, that is, using biology and physics to understand how tropical ecosystem, lagoon ecosystem work, and looking at the impact from essentially the human use mainly in the watersheds, and of the climate change, and trying to understand, is there any hope for them? They're all going downhill. Is there any hope in face of those threats? And we found the hope is actually in the culture of the people. In some places it will work. In other cases, I believe they are doomed. So I have 8 topics, starting with the Great Barrier Reef within Palau, within Hawaii, also within Pohnpei, and also with Fuhabei in Guam. I briefly talk of the lagoon in the delta on the coast of Asia, the major ports and harbor on the coast of Asia, and then some conclusions. SUN ecohydrology is a theme which, of course, you know well here, because this is one of the key centers worldwide for it, and it is a fantastic center. You are very fortunate to have it here under Lewis. And basically, it's looking at the interaction of the physics, the hydrology, with the biology. And there are the feedbacks, and that control the ecosystem health. In order to, because there is land use within the watershed, you have to look at the entire watershed. And now with the climate change, you have to also look at the impact of climate change. So it becomes very complex. So the sites where I will talk about are mainly on the other side of the world from here. In northern Australia, the Great Barrier Reef, within Palau, Guam, and Ponape, within Hawaii, and then on all the major ports on the coast of Asia. And in terms of the actual lagoon, I think the theme I'm saying is that some of the lagoon probably will not be recovered with the climate change and with human impact. They're going to keep on going down, and the ecosystem health will just die. And those two have a change because of the traditional way of life, the culture. So let's start with the one we did the most work in northern Australia on the Great Barrier Reef. Now the Great Barrier Reef is a huge system. It's over 2,000 kilometers long, but it's being stressed from the land and from the sea. The land is, of course, the land use, farming, the pesticide, and the fine sediment. And the stress from the sea with global warming and with a decrease in the pH of the sea, the acidification of the sea. And really, and this is a case you will have here too within your own lagoons, you can afford various types of thoughts of what will happen. Is what we do within Australia, and you could move this to what, if you work in your type of lagoon here, is the same idea. It's what you can do, and it's what the world can do. So what we can do, we can focus on GDP. So essentially, we just keep on farming the way we are. We have a lot of sediment coming in, a lot of pesticides, and we fish it to death. Or we can focus on social and environmental well-being. Both Costanza called it the GPI. So we can go from here to there, and in the same manner, there is the impact of the climate change, which is happening. And again, it can be two set of rules. If you make it simple, the world focuses on the GPI, and we stabilize the climate change to, let's say, 350 ppm of CO2. Or we just keep on going, we pump in, we burn all the carbon, And we go to, let's say, by 2100 to 970 ppm of the CO2. So really, where we will be by 2100, it could be in any of those 4 different carbon boxes. So what you can do and what the world can do. So what is being done by a reef? We try to manage the fishing. They are about a bit less than 1/3 of the barrier reef is closed area, no fishing. But that's on the map. But in practice, only about 10 to 15% of the reef themselves are closed. And in between, there is extensive trawling. We have closed the fin fisheries because the fish, when they spawn, will form big schools near some reefs. And they've been closed. At first, it was 3 times a year for 9 days. That's when the fish come in groups, the aggregate. Now, because that's the first sign that we are starting to lose some of the battle, because of the heavy pressure from the fishing industry, it has been cut down to two times a year. We close it for 5 days. And then for people who fish for fun, for a living, the recreational, there's a bag limit, but that bag limit is so big that you cannot basically fill your bag with so much. With the global warming, there is a carbon tax, and in fact it was passed 2 weeks ago. We are one of the few countries with a carbon tax, that is, if you burn carbon, you have to pay a tax. The third issue, but the tax is very low at this stage. The third issue is the land use. The plan, which was drawn in 2003, there was no action because of pressure from the farming industry. It was next revised in 2009 with some action. The plan called for halving the N and P, and also the pesticide which is coming from the farm. And in terms of the fine settlement, a much smaller decrease, only 1/5, 20%. And they were hoping that it will have an impact on the reef by 2013. So there are 2 actions. One is with the government in Queensland, and one is with the Commonwealth government. It gives us sum of money of $200 million over 5 years to the farmer, but only if they wish to join. It's to help to better manage their land, to have less soil erosion and less the loss of pesticides and something like that. A lot of farmers don't care. So there's some action in the state of Queensland with the beef grazing to try to tell them you have to have a certain value minimum land cover, that is keep on trees and some grass. The sugarcane, there's some action, I mean that's a law then, that they are obliged to do it. To try to have control on the use of fertilizer and also what they use on the land, the spray, the pesticide. This is opposed by farmers. We live in a free country, and if they don't like it, they will fight it. And they were marching on the street in some small town, the farming town. So it's not easy to force a law onto people who don't want it in a free country. It is very difficult. So there is a disconnect in Western society between looking after the land and looking after the sea. And that's a theme that I will come to, why it's so difficult to help to save the barrier reef and the other lagoon that I talk about. So this is, we have our flooding, our rains are short-lived not in Australia, and they last typically a few weeks. During that time, here's the land, here's the sea, the reefs. Every one of those very rivers floods, and they form plumes. And under plume reach the reef. And they carry with them the fine sediment with the nutrients and also with what you spray on the land. So most of them come during those floods. You can see the plumes which are forming, and the time is in days here. It's all done in the months. It comes and goes in the months. If the land derived waste were carried in the water conservatively, that is, they're moving with the water, they'll be flushed out in a few days or weeks. You won't have any issues. But they are not conservative. They are not moving with the water. Because, so if you look at the water, it's flushed out in typically 2 weeks in floods and up to a year the rest of the time, but there's not much coming the rest of the time. The coarse sediment is there for thousands of years. The fine sediment is there for tens of years, at least 100 years. Then if you look at all, sorry, I put in my pocket. If you look at the rest with the N and the P and the herbicide, it's a matter of years. So they are pushed in the water in a few days, but they are there for years. And again, the trace metal, the lead, etc., it's tens of years. So if we can fix the land use, and I must tell you that we are pumping typically anywhere from 5 to 15 times more fine sediment than in the past. And of course, all the new fluxes of nutrients are all new, so we have a huge impact. So if we could recover the actual quality of the substrates on the bottom, which is the first thing you need to do to have regrowth of the reef, but that will take tens of years, because it takes time to flush that out. So the 2013 target will not be met. Now, if you could wait tens of years, then reef recovery should be swift once they have clean water and a clean substrate. But then the new threat is coming in, it is climate change. So to predict what will be the Great Barrier in the future, we developed tools, various tools on the modeling. So we look at reefs. Each reef has a set of ecosystem with the coral, with the algae and the fish, and occasionally infestation of the crown of thorn starfish, which eats the reef, the coral. They are in the water column. Once in a while they spawn, and the spawn drifts around with the water current. They are being forced by storms. They are being forced by plumes, which is coming from the land, by the mud, and by the global warming. And so we have developed this type of model, which we check, for instance, for the live coral on the reef, at one reef over time, from the year 1969, 30 years worth of data. And this is a plot observed versus from the model at a lot of reef shown on the map for data 4 years ago. The same manner, there's a crown of thorn starfish, the map of the Barrier Reef, about 400 kilometers. There was a bloom which started off Cairns, and then it was spread with the lava, spread with the water current when they blew. And it spread over the whole Barrier Reef. And so all those things agrees. So that's what we predict for the future. The mean live coral cover for the Barrier Reef from the year 1969, which is our first data set. Last data set is last year, 2011. And those big circles there and the crosses is the data. That's the mean for all the reef which are surveyed. So there's been a big drop. We have done a modeling. We got that curve and we go up to here. And in fact, we are, based on the last data last year, we are much too high as it is. It has gone down even faster than we thought it would. We are down here. And then you got 4 different curve scenarios, according to what we do in Australia and what the world does. So if the world does not fix the climate change, and we either fix the land use, we will end up here. And if we don't fix the land use, we have lost our reef by 2050 or 2060. If the world fixes the climate change, then we will end up with a reef which is more or less what we have now. And obviously, the climate change issue is not going away and it's not being fixed, so it looks pretty bad. Now, Palau is a small island, typically 30 kilometers long with a few bays here and there. And from the outside it looks beautiful, a lot of mangrove, coral reef, very blue water, it's nice and warm, it's beautiful. But in that one bay, the Harai Bay, which is the first one that was where the land was developed for an airport in the Second World War, it looks beautiful, but the reefs are utterly smothered by mud and lots of algae. That's what they look like. There's no reef left of coral. So we train, I was part of a group of a few scientists, not only 3. We train a few local scientists in Palau, and they show themselves that the wetland, the mangrove, trap 60% of the mud coming from the land runoff. And but the net inflow of the fine sediment is 10 times larger than what it was in the past. Local scientists show this to the local people, the community, the leaders. Now they had lived on that island for over 500 years in a sustainable manner, because if they did, they'd be dead. There'd be no more trees, no more fish, there'd be nothing. It's a small island. So they understand in their culture the link between the land and the sea. So when those scientists, their own scientists, spoke to them in their language, and I explained to them with scientific data that what they knew in their culture makes sense, within one day they passed a law to stop cutting of the mangroves. Now, I don't know any place in the world where a scientist has managed to have a law passed within one day. It was fantastic. Within a month, the Parliament has passed a law which would actually protect the banks of the river with the green belt. 8 years later, I was there just 6 months ago, the reefs are slowly coming back, but it's a very slow process because the mud doesn't flush fast. It is, the waves have to come to 1 meter gap there, so there's not a lot of wave activity, but it is flashing slowly. As we say, it takes tens of years, but it is coming back. There is hope because they are looking after the land. And in the rest of Palau, what is fantastic is that those same leaders around that bay have passed the message to the other leaders in the rest of Palau, around all the other bays, just be careful. And because it's the 500 years of that way to look at the land, they are getting the message. And they are very careful. There is a chance there. And one good habit they are planting a food, the crop, the taro, which is a food, which is a plant, and they form a sort of a wetland where you can, and that's what the plant looks like, and it takes about 2 or 3 years, and they eat the roots, which have to cook special way. But that's a wetland which traps a lot of sediment. That's part again of the world culture. So, when the climate change comes in full swing, then there is a hope for the reef and the lagoon that it will be hardy enough, healthy enough, that it will survive climate change. The new threat now is poor farming practice, where they import farmers out of China and out of the Philippines. And those guys don't know how to farm in the old way. They just dig all the dishes straight down the slope, which brings a lot of mud, while they used to farm along the slope, along the terraces. Hopefully they will learn. Even in Palau, they start feeling the rise in the sea level. And some of those from the taro field start to receive salt water at a few places. So it's there. In northern Australia, in some of the lagoons on the northern Barrier Reef, we also feel it. We can see that at some very big tide now, you have the sea water which is coming in, and you can see how it runs along the roads, and it starts to flood in. Because we are a big country, at least in Australia, we have a very simple solution. If you become flooded, you cannot leave the sea level rise, you can simply move out somewhere else. It's the case within Hawaii, along one of the suburbs of Honolulu, which was developed in the 1960s. So they built a lot of housing in the valleys, and where there used to be a stream that would drain the hills, they have paved that to force all the water and the mud coming out straight to the reef, so that it doesn't flood in the township. Of course, that mud has killed the reef, and it has also, and a lot of that mud has been trapped by an invasive plant, the algae, which looks like this, and it traps enormous amount of mud. And when the tide is low, what it looks like is that plant there, invasive algae, and it's pure mud. They had a major program where they cleared that by hand, and we estimate it will take about 3 years after the plants are pulled out for the mud to be flushed out during storms. But the land use issue has not been resolved. They talk about how they build big traps in those drains, the canal, to try to trap the mud. It hasn't been done yet. The climate change issue is still there, but because you don't have any coral yet, it's not a big issue. For the people who live along the the beach, the view with the surf, it is utterly fantastic. Some of the most expensive beer houses in the world. And they don't care if they have a life system there, from the ecosystem. But what they have lost, without the actual coral, you don't produce the coarse type of sediment. The coral falls into some sort of rubble, and it is, so the reef always produces sediment, coarse sediment, which form the beach. So in the year 1930, that was a utterly beautiful beach. Nowadays, they got a lot of seawalls everywhere simply because they've starved the beach. There's no more coarse sediment being produced. So again, it's a disconnect between the use of the land and the use of the sea. Here is another case in Pohnpei, Micronesia. It again is a very small island, maybe 30 kilometers of the lagoon all around, and a few rivers. This is the one where we have worked, and we have trained a few scientists. A lot of the forest in the hills was destroyed to plant the sakao. Sakao is a plant, a narcotic plant, which they use at home, and it's an area very heavy rainfall, 8 meters, and that would generate a lot of soil erosion. You can see here all the mud has come down in a big block. That mud gets at the mouth of the river, it spreads, half of it goes within the mangrove, then the rest spreads on the reef, in the lagoon. And again, we have trained scientists there. We trained 2 scientists. They did the work, and they showed the work to the people who live there in the villages. And again, like in Palau, they had a 500 years old tradition to live with the land and the sea. They view it as one ecosystem. And they were far-sighted. They adopted ecosystem-based management. They went to force all the people who were farming sakao from the hills out. And they gave them land to farm. They gave them land in the floodplain where it's flat, a lot of less erosion. They created a very major reserve with the mangroves, which is a no-take reserve, and they want to create another reserve on the reef. And they help those people who were moved out from the highland to move back. Very far-sighted, because they have 500 years of culture to see the land and the sea as one ecosystem. What they're hoping for is that they will have a healthy type of an ecosystem when they are hit by the full effect of the climate change, and that will hopefully cope. And they're trying to move a lot of people out of fishing and the use of the reef, so the reef is less stressed. So it may work because it's not too late. They're trying to fix it before the problem. Once again, within Guam, it's a place in the U.S. Land, and it's a small bay. It looks beautiful because you have got the green belt. But if you look up the hills, the land has been utterly stripped of trees and vegetation, and you have very muddy river flow after rain, lot of erosion, short-term floods. It's not a big river, the floods spread at the surface, and they drop all the mud falls out of the plume, and it falls on the reef and on the substrate. So what's important in net budget, how much mud comes in, how much mud is being flushed out. Being flushed during major storm in a cyclone. So what's important is like in your bank balance, you have got some money going in and some money going out, and the same for the reef. What's the net budget? Is there more mud that comes in than what goes out? In this case, there's more mud than what comes in. So it's a well-flushed system, but there's so much mud coming in, it's not flushed fast enough. So in order to cut down on the soil erosion, people who live in the village have received a lot of young trees, the seedling, that they plant in the hills. And they teach the kids about the sea and the land, and it's a very powerful message is passed. But again, it's a disconnect between the land and the sea. Some people come at night usually, and they burn the grasslands, which kills the tree seedling, because they want clean land so they can hunt deer, they can see them from a long way. And it's an entire disconnect between the land and the sea again. And in society in the West, we haven't found a way, whether it is in Australia and Guam, to link the land and the sea management. So those reefs have no much chance. Okay, I have to go very fast. In Southeast Asia, the big issue on the coast is that the issue of the sinking delta. For a lot of reasons, the big dams have trapped a lot of sediment. They're trapping sediment. So you always have a wedge of sediment of shape that can vary according to what's happening. And you had lots of sediment, long-shore transport, some being lost at sea. But now you have cut down the source. There's a lot net of inflow which is coming in, which is the mud or the sand, the sediment. So the net budget here, the sediment is a loss, and the coast is moving back. The other reason is the mining oil, water and gas from the ground, people pump. The last reason is that as farming, a lot of the water, the sediment again, is just being comes out of the river and goes on the farm. So all the major delta of the world have a decrease of the load of sediment of at least 50%. Some, like the Nile, is very nearly 100%. There is no more sediment. And those are all those, well, here's the Nile. 98% of sediment has been cut off. Those are all the major delta. This is which one of them is being mined for oil, gas, or water, but you pump from the ground and it's sinking. And how much do you take out for farming? They used to grow in the vertical upwards by rate anywhere from 1 to, let's say, 6 or 7 millimeter a year, 100 years ago. Now they are sinking at a rate of 5 up to 25 per year, millimeters. So they are sinking. And a lot of the big cities, a lot of farmland in the world, the best productive farmland and the biggest city in the world in Asia are in the delta. They are under threat of both the climate change, which is going to make this rise even faster, and the use from the land because it's sinking. And of course, lagoons in those areas are all are also starting to breach to the sea. It's a tremendous problem. And so the problem is that if you have got an environment which is degraded significantly, can you recover it in the estuaries? We spoke with the modeling in some units. I'm not going to define here, but those are one that I can show you. I plotted the total human impact, the energy which is removed from the system, energy fluxes between different boxes in the ecosystem, against the health of the system. Once the system is perfectly healthy, if it's zero, it's dead. And those major faults in harbor, in Darwin in Northern Australia is in good health, and they fall on that line, and the worst one is the one is in Shanghai, and also the one and one just to the north of it, in Hong Kong. They suffer a tremendous human impact, and they are really on the way down to the health. If you take, let's say, Hong Kong, with 30% human impact, is 30% is being, health is being pumped out every year by the human use. Even if you could cut that down by a factor of 3, so you go from a HI of 30 to HI of 10, it will still slide down, it will go down to 0, it's on the way out. And so, if you cut it down to 5, then it can start to, its health will start to get better. If you cut it down to 1, which of course is not possible with what's going on, then it has a chance to come back. And in none of those systems is climate change planned for. Not one of those major harbors is planning for climate change. So, just on time, the last thing, the baggage of the past history is that we have ignored eco-hydrology. Land use is addressed, but weakly, for the Great Barrier Reef lagoon. The lagoon is already degraded. There is an attempt to prevent climate change by a carbon tax. But to make it work, the whole world has got to join in because the system is quite low already. Some lagoons of Micronesia may be healthy enough and strong enough, resilient enough that they can hopefully survive climate change because there's an attempt to adopt ecosystem management that follows 500 years of sustainable living in small islands. Developing the economy versus the environment is still much the practice along the coast of Asia, the Pacific. And in terms of the change of climate, it's not even on the planning agenda. Like in my town, in Townsville, the port is booming because of the mining boom in Northern Australia. It's really booming, and they're not, when they build the new roads of access, railway access, they're not even planning for a rise in the sea level. It's cost for those people who will have to face it in the future. Tokyo Bay, Singapore, and Pearl Harbor. Care of the environment is now the rule and the law. You have clean water, but life in the marine environment is very sparse because they have lost the habitats. And those systems do not provide the basic type of services, ecosystem services, like having the clean water, clean beaches, fish, that we can enjoy life, it does not provide those type of services to humanity. So it is a very gloomy story, but I'm hoping that as young people, you will help to find a solution. Thank you.
Thank you, Eric, for this wonderful talk. I would like to ask if there is any question to Eric already. If not, while they are singing, I would like, of course, to thank you again more for the talk and to ask, well, we can see, in fact, that there is this kind of disconnect between land use and coastal management. And this, of course, is based on the human aspects. From your experience and things that you have shown us from different parts of the world, it seems that there are different approaches also and different feelings of the human dimension to this kind of problems. There was this example that you showed very interesting from Palau. So what is the future? So how can we, in terms of our scientific work, address these politicians and show them any way that this is important? So what was the key for success in the situation in Palau, and why is it more difficult to have the same let's say, receptivity in other regions? It's a tough question.
That's a very tough question. I don't know the situation. It's a matter of course, in Palau and in Pohnpei, they have 500 years of history that they had to live on an island, small island, so they had to be careful. They had to manage the two at the same time. The world in the Western world has never had to do it. I don't know the solution. I can only suspect that your idea to have a few sites, demonstration sites, could be one way to try to pass on the message. But I don't have a solution. Maybe you need people in the field of social sciences involved in those issues, but I think this is one of the major issues we are facing in humanity. It's that disconnect between the land and the sea. I don't have a solution.
No, but I think it's a good point, and I really think that even our course, I think that course that we are running in terms of ECOHYDROLGY that tries to bring together these two approaches, it's important from this aspect, because I think one thing that happened before is that people had this very closed education in land use or in coastal or whatever, and things were not put in a more common framework. And I really think that this course and other courses, of course, around the world that are trying to do this will be helpful, and that also this more holistic approach of bringing social sciences with natural sciences together, and people are starting from the university point of view and as students already to understand this need to dialogue together. It's very important. When we probably were studying, things were much more separated than they are now. And well, if there is any more questions, I want to thank you again. Also, because we have a limited amount of time to webcast this conference, I want to thank you again. I want to thank everybody here, and I want to thank everybody that assists this conference through the internet. And I will mainly send my best regards to our colleagues and students that are in Poland, that are in Kiel, that are in Delft now, because we have students all over Europe. And it was a big pleasure to are in contact with you all today. Thank you again, and we will be back to another of these open lectures next month, and hope again to have you all with us. Okay? Thank you. Bye-bye. Thank you so much.
Thank you for coming.